second session of the morning. After this, we would have a lunch break. But for now, Eric Shepard with the hidden gems of the Apple IIgs Toolbox.
So yeah, I'll be talking about the toolbox and talking about some of the more interesting things that people might not be aware of, or things that are easily overlooked. So let's get started. The toolbox is actually pretty big. There's 32 tool sets or so. It depends on which ones you count. If you count some of the third-party ones, it's bigger. There's over 1,200 calls in the toolbox, and I was too lazy to get an exact count. But it's a lot. So what we're going to do is take a look at just a handful of things that you might not have noticed, or maybe you looked at years ago and was like, oh, that's interesting, and then haven't thought about ever since. One thing that's kind of cool that you can do is you can make the mouse do your bidding. What's interesting about this is that, as it turns out, you can control the mouse from software. Now, this is kind of hidden away, and this is a true hidden gem of the GS Toolbox, because the discussion of this is actually talked about in this obscure section of the Event Manager documentation that talks about writing input device drivers. And so it's one of those things that you kind of glaze over as you see it. You flip past it as you're looking through the documentation. Sometimes you want to automate something that there is no support for in the toolbox, like scrolling scroll bars, for example. And there is actually a tool call that lets you do this. It's called Fake Mouse. And it's hiding there in the Event Manager. This is the toolbox reference page for it, for Fake Mouse. Allows an alternative pointing device, such as a graphics tablet, to be used in place of or in conjunction with the mouse. This call must only be made by a device driver. Well, that's not entirely true. It's just, it does weird things to people's, perception if you use it improperly. So let's take a look at these routines, and it uses some very odd, the inputs are a little strange. So let's take a look at those real quick, what they do. Up at the top, you have the changed flag, the first parameter. It has 2 bit flags in it, which you set to indicate whether the position, the mouse button state, or both have changed. So basically, you can tell it whether a button has changed, whether the position has changed. The Event Manager can use that information to decide what stuff it needs to do as it interprets your call. And then you pass in a value for the modifiers. This is literally the same format as the I/O address for the modifiers. So you tell it, here's the state of what the modifier keys were at the moment that this mouse activity occurred. And so then there's some padding. You just ignore that. You do have to put the modifiers in the, I think it's in the high byte here. If you're just moving the mouse around, generally you don't use that. And then you pass in the X and Y positions in absolute screen coordinates for your mouse, where you want the mouse to move to. You can leave those as 0 if you're only changing the button state. And then comes the button status. And it has multiple bits, 2 bits for each of the buttons. And you don't really use button 1 very often. That would be a right click. Button 0 has 2 bits, though. Bit 15, the highest bit. You specify the current state of the button. Is the button currently down or up? And then bit 14, it's the previous state, so that you can tell it, the state has changed since the last time that you called Fake Mouse. Using Fake Mouse is actually pretty easy. It claims the call cannot be made from C. That's not true. It can be. The reason they claim that is because of the at the time it was written, the C compiler, that's documentation was written, the C compiler was crap. Because here I am using it from C. This is code ripped right out of Sweet 16's extension, actually. So the first one, basically what this code is doing is this is just clicking the mouse at a given mouse position. What we're doing is we're moving the mouse to a position, clicking, releasing. That's all this code here is doing. So this first line of code, we're specifying 6 for the change flags, the flags. And basically that's saying that both the button and the position of the mouse are going to be changed by this called fake mouse. And then we're passing in modifiers of 0 because we're not doing anything with the modifiers here. And then we pass in the X and the Y coordinates that the mouse needs to be moved to. And then our button flags. What we're doing here is we are saying that we've got the high bit set, the low bit is clear, or the second bit is clear, bit 14 is clear. That's saying that the current state of button 0 is down, it's pressed. Previously it was not pressed. So that is, this is a new click that is occurring at this time. And then we go on to this next line. We're saying the button state has changed, but the position hasn't. So we're not moving the mouse, we're just changing the state of the mouse button here. And then, we're the position, actually I could pass zeros here, it doesn't matter because we're not moving it. And then the mouse button, we're saying now it is not pressed, but it was before. So after this line is executed, the mouse will still be at the position it was at before, but now the mouse has been released. So the result of this is we have simulated the mouse being moved, clicked, and released. This can be used for a lot of stuff. You could use this for example, in a Finder extension. You could use it for clicking and dragging icons around on the screen if you want to automate or create a way for scripting, moving stuff around. I'm actually using it right now for an add-on that will click and drag icons to the trash automatically to simulate a move to trash command, which does not currently exist in the Finder. I have it almost but not quite working right now. I was hoping to actually show that in action, but it isn't quite working. You can use it to do things like automatically activating menu options that don't have keystrokes. You can use it for, literally for drawing things on the screen, taking command of the user's mouse to, in a help system, to show how to do things and actually have it do it as the user, asks you to, teach them how to do something. There's a lot of stuff you could use this for. So it's quite interesting. And I don't think I can think of anybody who has really used it, at least not that they made a deal, made a big deal out of. And of course, it could also be used for writing a device driver for,
Yeah, it's probably used for the Joy mouse
right,
driver.
exactly. It's been used for things like that, but otherwise, probably not. So the next thing we're going to talk about is queues. Queues are a really common data structure in programming. They basically consist of records of data, and each record has a pointer to the next record in line. And then the last item, its pointer is null, saying, okay, there aren't any more. Null being, speak for 0. This is really common in programming, and one thing that was done in System 5 is they added 2 routines to the miscellaneous toolset, add to queue and delete from queue, that let you manage queues easily. And these are used primarily for specific types of queues that are used by the operating system or by other toolbox routines that you can use to manage specific queues, and we'll actually look at a couple of those here. But let's first look at the generic implementation of queues provided by the miscellaneous toolset. So each queue has a header, and it starts with a long word, 4 bytes, which is reserved. It's used by the operating system, by the toolbox, to maintain a link to the next record for you. Then the next word is also reserved, and you should set all of those to 0 when you create your queue record, your header record. And then the next 2 bytes are a signature. It should be set to A55A, and that's used as a signature to basically say, okay, this is a legitimate, valid queue header record. If that gets corrupted, then the toolbox starts giving you error messages and stuff like that. In fact, if that gets corrupted, that's when you'll start seeing, like in the heartbeat queue, if that record gets corrupted, you'll get that fatal system error where it starts flashing, heartbeat queue, contaminated, corrupted, whatever it is. So you have to create the first record yourself. So you create your first queue record using this structure. But then when you want to add and remove stuff to the queue from there, because that first record is basically, it's used almost like a queue identifier, that first record in your queue. After that, you can then start using the tool calls to manipulate the queue after that. Here's the add to queue routine from the documentation. All you do is pass in a pointer to a new header record and a pointer to the first entry in your queue, which is used to identify the queue. And basically, the routine will validate that the signature in the header is correct, and then it will insert it into the queue for you, returning an error if it's already in the queue. And similarly, there's delete from queue, where you pass it in the pointer to the record that you want to remove from the queue, pointer to the first item in the queue, and it will go through, find it, remove it, and fix the pointers to bypass it for you. This is all code that's really actually fairly easy to write yourself. I mean, queues aren't hard to work with. They're not super complicated. But it is kind of a nice convenience thing to have. More importantly, especially because it does some of the validation stuff where it validates to make sure your headers are intact and things like that. But the most important use for these queues is for the queues that are the uses of them by the toolbox. One of them is the out-of-memory queue. You can establish a queue of routines that this is a queue that is maintained by the operating system, and you add items to the out-of-memory queue by calling a routine called, I believe, add to OOM queue, which basically says, okay, whenever the system is low on memory, it can't allocate enough memory, call this routine and I will see what I can do to free up memory. So what happens is when the operating system gets a request, a new handle request, and it's like, okay, I cannot fill this request. It starts by purging memory, starting with the most purgeable stuff, because when memory in the GS, memory blocks can be assigned a value between, I believe, 1 and 3, how purgeable it is, how long it should be kept around before it's purged. So it starts by purging the least important stuff, then it tries to allocate again, and if that fails, it purges the next batch, and then the next batch, and then it does compact memory to move memory around to, so it tries this series of things. But the first thing it does is call the out-of-memory queue. Do you have any memory, it asks, that you don't need? Are you retaining caches of stuff that aren't important, things like that? So it calls you, and it actually sets a flag saying, okay, this is the first time I'm calling you. Don't try super hard. Just dump anything that you don't need urgently. And it tells you how much memory it's trying to get. So you look at that and say, okay, well, I have some caches I can dump. Let's dump these, and that gets them halfway there. Not all the way, but halfway, and that will return. And then the memory manager will try and fill up the rest either by calling other things in the out-of-memory queue, doing more purging, and so forth. When it runs out of things to try, it calls you a second time. If it's not able to fill the memory request, it calls you a second time and says, okay, now I'm really desperate. It sets a flag saying, okay, now dump everything you can. I really need this memory, or basically somebody's going to be hosed. And so then that's when you start dumping, stuff. Okay, well, I could reload this from disk if I have to. I can regenerate this table if I need to. That kind of thing. This is a really good way, really good and badly underused tool in GS software. Very little GS software takes advantage of this, and really, it's a really good way to help people, especially on lower memory machines, like a 2 megabyte machine, run stuff that is borderline on whether or not it'll fit on their machine. And I would like to see more people make use of the out-of-memory queue, because it's really a nice way to make applications more compatible, more broadly compatible on lower configured machines. Another kind of queue, and this one to me is more interesting to talk about, is the run queue. These are background tasks that run when it's safe to run them. This is different from the heartbeat queue. The old heartbeat queue, it would get called based on the vertical blanking interrupt. These would get called at interrupt time. So there wasn't a lot you could do in them. It was basically a matter of, okay, well, I can set a flag, or I can call the scheduler tool set, which is another one of those often unused things, which basically says you can call the scheduler and say, okay, I have something that needs to be done when it's safe to use the toolbox. Schedule me, call me when it's safe to issue toolbox calls. And so you could do that from the heartbeat, but that's about it. A run queue task is run when it is safe to do stuff. You can specify how many ticks to wait until you're called, and you'll get called after that many ticks. It's also different from a heartbeat task because a heartbeat task automatically gets run every however many ticks you specify. A run queue task runs in that many ticks, but does not get run again unless you specifically reset your counter. Because what happens is your counter gets set to 0 when your time runs out, and then it doesn't get run again, so you have to reset it manually. And there's a couple of nice things about that. Number one is it's great for one-shot tasks. Okay, I need this to run in 5 minutes. Boom, it's done. It's also nice for tasks where, okay, I need to run it in 5 minutes. Oh, well, okay, well, next time I need to run in, 1 minute. Okay, well, next time I need to do it in 30 seconds. Next time I need to do it 2 minutes. For whatever reason, there are some cases where this is useful. So you can change the time each time just by changing the number that you set to for your next run. So there are many reasons this is better than the old heartbeat queue. So this is a very short run queue task. They start with a header. It's the same header, 4 bytes for the link to the next item, and then that reserved thing. Well, that reserved thing that was reserved in the header, it turns out that it's used by run queues for the number of ticks until the task should run. And then comes your signature. Now here we've set it to 60 ticks. That's 1 second. So you do your stuff, and then in this case, we're just resetting the period back to 60 ticks by writing there. So once we return with the RTL instruction, in another 60 ticks, it'll get run again. It is not precise, obviously, because what happens is after 60 ticks, the system goes, okay, when can we do this safely? So after those 60 ticks, it will do it. I believe it does it as the system task or something like that, event manager routine returns, meaning I have finished processing events. The toolbox is in a safe state. Now let's go through and call any pending run queue tasks that are waiting to run.
So the code itself goes in the element right in the record?
Yes. Yeah. You put the record and then the code follows it immediately. Just like that. Yes, that's a good question. And that's how it knows where to find the code. Because when you call add to run queue, which I will, I thought I had a slide showing the actual code. Basically, you pass a pointer to this header, and it knows where the code is because it follows the header immediately.
Because that was something I was wondering earlier when you first mentioned the header for the queue.
You just
how does it know how big the record is?
It doesn't need to know. because it doesn't move it. You allocate the memory, you leave it where it is. It doesn't move it. It just creates the links from one block to the next.
Gotcha.
That is also a good question. So yeah, and then there's also a routine that you call remove something from the run queue when you're done using it. So this is all covered in Toolbox Reference Volume 3. They were new in System 5. Really awesome tools for setting up scheduled events, and really, really, really convenient and handy, especially in things like desk accessories and extensions and things like that, when you've got stuff you need to do periodically. Okay, so next we're going to move on to what I call fun with strings. The GS's primary character set is ASCII. In fact, it uses, the GS Toolbox uses an extended form of ASCII called Mac Roman, which offers a lot of special characters with, like pi and characters with accents and things like that. But what do you do when you need to take those strings and display them on the text screen? Well, you could, write code to go through and convert. But it turns out there's actually a Toolbox routine that does that for you. It is called string to text. It's in the miscellaneous tool set. It was introduced in System 6. It's a really nice routine, actually. What you can do is you can pass in your a pointer to your source text, how long is your source text, and then a buffer to copy the converted text into. You can also specify whether you want the text to be in US English, British English, Greek, whatever, based on what character set your screen is going to display it in. And then by default, it uses whatever the active character set is. So that's almost always what you're going to do, is just say, just the default character set. You can also specify whether the text is allowed to use mouse text, so it can convert your string so that it will include mouse text characters under certain circumstances. There's one other flag. I think I may mention it on the next page. Yes. There's also a flag that indicates whether or not to strip out characters that can't be converted. So what happens is it returns a string that does its very best job converting, and it will do things like convert the copyright symbol into a C in parentheses, for example. And it can strip out characters that can't be converted at all. I don't know which characters those are. But it'll do things like if it's an A, with a U with an umlaut, it'll just turn it into just a U, for example. Things like that. There's some interesting tips to keep in mind when using string to text. You have to provide a destination buffer. How big do you need to make this buffer? Well, the worst case scenario is you have a string that is all the trademark symbol, which turns into open parentheses, TM, close parentheses. So your worst case scenario is you need a buffer that is 4 times as big as your source string. That's an unlikely scenario, but unless you know a lot about the contents of the string you're converting, your best and safest bet is to go ahead and give yourself 4 times size buffer. This is used in the toolbox for doing things like when you're using when you're doing a GSOS thing, you're copying like a file from a Mac disk to a GS disk, and it contains funny characters, and you get that box that says, "Oh, this contains characters that aren't, ProDOS compatible. What would you like to change the name to?" And it suggests a name. It's used for that, for example, to convert the string. It's also used for things like when you're displaying a file name and it's being done on the text screen. For like, you need to insert disk, whatever. It uses it to update to draw that disk name if the name contains unprintable characters, things like that. So this is also a really nice, useful little routine. I actually intentionally have designed this to be a little bit of a short presentation, so we can have lots of time for Q&A and stuff like that afterward. So a few other things to look at. I've already mentioned the scheduler, which is really handy, and another one of those often overlooked things because it's really small tool set, has like 2 calls other than the required basic 6. So the chapter on it is like 5 pages long. It's really short, so it's easy to overlook. But I strongly recommend if you do anything that is non-application programming, desk accessories, inits, drivers, anything like that, look at the scheduler chapter because it's really handy and easy to use for scheduling stuff. Like if you're, I know that like in the Sweet 16 add-ons, I do things with it where I need to be able to present user interface, a dialog box or something like that. You can't do that in the middle of a toolbox patch, for example. So you call the scheduler, say, okay, I need this subroutine to be run as soon as it's safe to call the toolbox, and then I get called back, and it's usually within a matter of moments as soon as the toolbox goes out. Because what will happen is, as the toolbox, the tool locator ends, because you call a vector to call the tool locator, which then dispatches the toolbox routines. As all of that chain of returns comes back through the tool locator vector, it then looks at the scheduler queue to see if there's anything pending, and if there is, it calls those routines until it's all out, and then it finally returns back to the caller. So it usually happens extremely soon.
How low level, can you call that maybe from a GSOS?
Absolutely. You can call it from anywhere. You can call it from interrupt routines, you can call it from device drivers, you can call it from ROM, you can call it from anywhere. The scheduler is one of those tool sets that's built into ROM. It does not need to be started up. It's just always there. Another thing to remember always is a lot of people forget to go and look through Programmer's Reference for 606 and 601 because they came so much later than the other books. There's a lot of awesome stuff in those, and don't forget to look through them because oftentimes even I will do that, and I have them all right there all the time, but I'll often be like, okay, there's got to be a way to do this, looking through the toolbox references. It isn't until later that I think I should go look at these other books. So absolutely don't forget to look through those. And with that, I am ready for some Q&A time. Anything about Toolbox, any weird stuff you've always wanted to know if there was a way to do it, anything.
I would assume you recommend the ByteWorks books if you want to learn Toolbox.
Yeah, absolutely. I would say if you want to learn how to do Toolbox programming, the ByteWorks books, Toolbox Programming in C, Toolbox Programming in Pascal are both good. Which one you choose depends on, obviously on whether you want to try and do it in C or Pascal. But Pascal is a little easier to learn as a language, but C is a little better suited to Toolbox Programming than Pascal is. I only know one person who was like diehard Pascal Toolbox programmer, and that was Ryan. So, and he's not here to defend Pascal as a GS programming language anymore.
Well, I know Pascal and I don't know C, so that's sort of the...
Well, that works then, and the book is good, and it kind of helps you learn the little idiosyncrasies to working with the toolbox in Pascal. So, yeah, that would be a good way to go. If you happen to have the Opus 2 CD, it's on there. If you don't, Tony can hook you up.
So what's the status of how to program Toolbox in GSOC Basic?
I believe I released the partial of that. It's never going to be finished.
Okay.
Because I got to the stuff on printing, and we discovered there were things that just did not work, that you could not do in GSOC Basic there, and so the book just stalled at the Print Manager chapter. But it does go through working with controls, menus, windows, stuff like that, resources. So it's pretty good, and I believe it is posted. It has been posted somewhere. I do not remember where it is offhand, and it may not currently be available because I don't recall putting it on my new website redesign, so I'll have to look. If it's not there, it might have been on Syndicom's site for a while and not there anymore. I'll have to look and see where it is, but it should be available. Yeah?
I was just curious. I'm pretty sure you used that mouse trick when you were doing 16 and
Yes,
using the 2-finger
absolutely.
scroll.
Yeah.
You were just saying put the mouse over here
In-
and bring it
in
back
fact,
so quick you can't see it.
Yes, exactly. That's exactly what it's doing. It moves the mouse there and back so fast that you don't even see it move.
So that could be used for doing a VNC server.
Yes, it
type
could
of
totally
thing.
be done. Yeah, it could totally be used for doing a VNC server. It could be used for it could be used for one thing. In fact, there's something that was mentioned specifically in the programmer's reference for System 6 was adding a scripting language to the Finder, and it could be used for doing that, for moving icons from one folder to another, things like that, because they did not include a Finder request code for moving icons from one place to another, which is frustrating. That would have been inordinately useful, and they didn't include one. And that's what I'm trying to do now is dragging icons to the trash.
So you could actually do a smarter cleanup then by looking at the size of the icon that you're using and making sure that it's visible and you go around it rather than just doing a grid. Yeah.
Right, yeah, you could do stuff like, there's a lot of interesting stuff you could do with it. I'm particularly intrigued by the idea of like guided help and things like that. I mean, these are things that in practicality may never be done just because, there's limited, time for development, but it's the kind of thing that would be really interesting to be able to show people how.
I can't remember what system it was, but there was one that had an option that anytime an alert window type of thing, like the message box popped up, it would automatically move your button.
Yeah, you could totally do that.
Move the mouse to the button, so all you had to do is click.
Yeah. Yeah. Anybody else have questions or comments or?
I don't know, this might be too big for this question, but like, do you have like an overview of like the IPC? Because I know site like tells you messages.
Right.
It
Yeah.
doesn't give you how it works in general.
Right. The IPC on the GS Toolbox is all covered in Program's Reference for System 6. The docs are pretty good there. Basically, there's two routines for it. One is called accept request. You call it saying, okay, I want to accept IPC. Here's the name I'm called under. Here's my user ID. Here's the routine that you should call when IPC occurs. And then there's send request, which sends out a request. They're really easy to work with.
All those Finder.
Yeah, all the Finder request codes are documented along with all the data structures and all of that. Yeah.
But that's the mechanism that uses.
Right. You have.
Yeah, I've been trying to understand the resource definition of a window. And
Okay.
the final field in the definition, I believe, is called W-verb. I cannot find the toolbox reference. What should I be searching for? What is that? Okay.
Let me see here real quick. Toolbox reference volume. Are you looking at the new the resource you said, right?
The resource, yes.
All right.
I can ask you later. It's up to you.
Well, I'm kind of.
Question.
Okay. Verb.
Oh, it's the very last one.
Was in the desk. You're gonna have to hit me later because I don't see one called verb.
Okay. I've only seen it called verb in the comments, so it's possible that the comments I was looking at.
Okay. Yeah. If you can find that, I'd be curious to see.
I'll double check.
Any other questions or thoughts or, is anybody working on code that they're confused by? Because otherwise we're done really early. I was counting on more questions than this. People are slacking.
Well, I'm sure I'll probably come up with a bunch of them in 15 minutes or so.
Yeah. Exactly.